Lesson 12.1 Exponential Functions continues. In this video, we will write exponential functions to represent half-life situations and complete a table of values. Why do kangaroo moms hate bad weather? Because their joeys have to play inside. Write an exponential function a of t where t represents the escape time to represent each half-life situation. Then use the function to complete each table. Round as necessary. Since in the last couple sections we've been rounding to the thousandths place, as necessary will be to the thousandths place as well. Alright, so escape time is in hours in this function. Drugs in blood system starts at 120, goes to 60, and continues from there. And then the third thing is the half-life number, so how many cycles at each of those moments. So what this means is after 2 hours, we'll be at 60 milligrams of the drug in the blood system. After 4 hours, we're at 30, and so on and so forth. So its time is increasing by 2, right? We're multiplying by 2 here, or we're adding 2 to the time. Every 2 hours is where our half-life happens. And then the half-life for this is after 20 or 2 hours, it'll have gone from 120 to 60, so this is our half. From 60 to 30, this is half. From 30 to 15, this is half. So each time the half-life is going down, or each 2 hours it's going down by half the amount it started at. And then the last thing is, if you look at the top number, if we take 2 and we divide by 2, because that's what we're increasing by, that determines our cycle number for the half-life. So 6 divided by 2 is 3, 8 divided by 2 is 4, 20 divided by 2 will be 10. So just like in previous sections, we're going to be starting with that g sub n equals g sub 1 r to the n minus 1. And we're going to use that as our base for this problem. So instead of g sub n, we're going to use a of t, because that's what they've asked us to do. So we have a of t equals, our first term, our g1, is 120. Okay. The pattern is that we're taking half, but instead of using the n minus 1 like we did have in the equation, we're going to be using t, and we're going to take t divided by how long it takes to get a half, how long it takes for the substance to be half. So in this case, we're talking about the 2, so we're going to divide it by 2. And so that is how we write our function. And then we're going to take our geometric function and put it into an arithmetic, or a exponential function. So we have a of t equals 120, and we're going to take that t to the 1/2, or the half of t, and we're going to split it up as half times t, so that we can take that half and we can move it inside the parentheses. So now we have half to the half power to the t. And we can stick half to the half in our calculator, and we're going to get 0.70711. Now normally we round to like 3 decimals, but when we're working with a function like this, we want to expand our decimals to more, because the more decimals we have, the more accurate our numbers are going to be. So we're going to put about 5 in this one. Um, and we'll round our answers to 3 decimal places as needed. All right, so then from here, we want to figure out what we get when it's been 20 hours. So first of all, this is our exponential function. And we're going to plug in 20 into this function. And then we'll stick it in our calculator to evaluate it and get an answer. So after 20 hours, we will have 0.117 milligrams of the drug in our system. So what I'd like you to do now is try number 12 on your own. So go ahead and pause it and do that now. Okay, so hopefully you saw that it is taking 5 minutes for it to go from 800 to half the value of 400, and then 5 more minutes to go from 400 to 200, and so on and so forth. So then our function is a of t equals 800 times half to the t over 5, because again it takes 5 minutes to get half the amount. And then we can go ahead and bring that 1/5 inside with the 1/2 and stick that in our calculator and get 0.87055. And then this time it's asking for the 100th term, or after 100 minutes. So we plug the 100 into the function and we get 0.00076. Now this is why it says as necessary, because if we were only rounding to the 3rd decimal place, we would have like 0.001. So sometimes you want to just expand it a little bit and put a couple extra numbers behind the zeros to get an idea of what's going on. And with that, that's how we write exponential functions, where t represents time to represent each half-life situation.